Right, so this worksheet is the first worksheet of balancing equation worksheet. This is talking about synthesis and decomposition. So I will just first briefly talk about the notes, and then I will do the work on the bottom. So first of all, balancing equation meaning like you have to get both sides of the atoms equal. So if you have left hand side 5 carbon, you need to have right hand side 5 carbon. That would be balancing. You cannot have like left hand side 3 carbon and right hand side 5 carbon. That would not be balancing. So first of all, the notes here is that how do you figure out the total number of atoms? You got to take the coefficient times the subscript. So for example, if I have 5 have 2, how do I find out how many hydrogen? We take the coefficient times the subscript. So 5 times 2 is 10 hydrogen. If I have 5 H2O, by hydrogen, we do the same thing. 5 times 2 equals 10 hydrogen. But how do you figure the oxygen? You cannot just tell me that you have 1 oxygen, because this 5 is actually going to the water as well. So you put a bracket around the compound, and how do you figure out the oxygen is 5 times 1, because the number here missing, meaning that it's actually 1 oxygen. So 5 times 1 is equal to 5 oxygen. Now the second note is never change the subscript. So for example, if I have H2O, the oxygen is 1. I cannot change the subscript to be 2 and say that they're equal. I can't, because if you're changing the subscript, you're changing the compound, like you're changing from water to hydrogen peroxide. You can't change the subscript. I can change the coefficient, no problem, but I cannot change the subscript because you got to change the compound. And number 3 is you're going to put the coefficient in front, and then you're going to put the bracket around the compound. So the compound is the one with the multiple atoms, so you got to put the bracket around the compound, but you don't need to put a bracket around the element, which is only one atom. So for example, we have 2 KCl at the beginning, and I will have 2K and 2Cl, because I'm going to put a bracket around KCl, and then I can calculate all the atoms inside. If I have 2 Na2SO4, we have to put bracket around the compound. So you say, okay, I have 4 Na, 2 times 2. 2S because it's 2 times 1. 8 oxygen because 2 times 4. Now here, make sure you put bracket around so then the 2 does not just go to the first element, it goes to the whole thing. Now the coefficient must be a whole number, meaning that I will not have any fraction or decimal for the coefficient. And then you always check to see if the coefficient are simplified. Okay, but you cannot change the subscript. Okay, you always just check the coefficient simplify. So for example, after you balance the equation, if your coefficient come up with 2, 4, 2, 2. Now 2, 4, 2, 2 is not the simplest ratio. Okay, so they think about your math teacher may ask you to simplify. So think about 2, 4, 2, 2. What is the common factor? Will be 2. So I have to divide the whole thing by 2. I get 1, 2, 1, 1. So always double check to make sure that your coefficient is the simplest ratio. So if your answer is 2, 4, 2, 2, you think 2 beyond. So you have to simplify to get the simplest ratio of the coefficient possible. So your answer would not be 2, 4, 2, 2. Will be 1, 2, 1, 1, because you divide the whole thing by 2. So here, first of all, the synthesis is the same thing as decomposition, because the synthesis just like flipped of the decomposition. So here I put the equal sign on the arrows, just treat it as like an algebra thing. So left hand side and right hand side the equal sign. Okay, so they must be equal elements. So first of all, we draw the table with the atom and left and right. Okay, so I'm going to start with actually like a blank paper. So we write down, I have 2 elements. So if you have 2 elements, you gotta have 2 rows. So if you have 3 elements, you get 3 rows. If you have 4 elements, you gotta have 4 rows. Okay. So I have 2 elements, which is Ca and O. Right. So on the equal sign, all right. So on the left hand side of the equal sign, I have only 1 Ca. On the right hand side of the equal sign, I also have 1 Ca. And then oxygen, on the left-hand side, I have 2 oxygen. On the right-hand side, I have 1 oxygen. So it looks like the Ca is balanced, but the oxygen is not balanced. So how can I make the oxygen balanced? Now, since I cannot have the fraction or decimal places of the coefficient, I have to make a whole number, 1, 2, 3, 4, 5. So I cannot make that from 2 to 1. But I can make it from 1 to 2. So how can I make the oxygen balance is if I put the 2 in front of the CaO, I will make the oxygen balance. So this is a compound CaO. I have to put a bracket around. But this way, I'm not just changing my O, I'm changing the whole compound. So let's say, okay, I put the 2 in front, I put a bracket because it's a compound. So my Ca is no longer 1 on the right hand side. My Ca is actually 2. All right, it's actually 2 Ca. And my oxygen is 2. So actually my oxygen is balanced. But then now I change my calcium is not balanced. So 1 to 2. So how can I make my calcium balanced? Is if I put the 2 in front of here. This one I don't have to put a bracket because it's an element, so it's very simple. So I change my Ca to be 2, so I have to change it to here. Right? So you look it up, are they all balanced? Yes, because everything left hand, right hand side, they're equal, so they balance. Now, when everything's balanced, if I have a leftover coefficient, that leftover coefficient must be 1. So this is my answer. Okay, now you only put the 1 at the end after you make sure that everything's balanced. You don't want to start with the 1 at the beginning if you're not sure they're not balanced. Okay, now here I'm going to put the equal sign here too. Right, so I have 2 atoms. One is the N, one is H. So I have 2 nitrogen on the left and 1 nitrogen on the right hand side. I have 2 hydrogen on the left and 3 hydrogen on the right hand side. So it looks like I can start with simple, would be start with nitrogen. I want to make the nitrogen balance. So I'm going to put the 2 here, right? And I put a bracket because it's a compound to make the nitrogen happen, balance, but then I change the whole thing, right? I put the 2 here to make the nitrogen on the right hand side would be 2. But then I will also change my hydrogen, right? 2 times 3 is 6 on the right hand side. Now my nitrogen is balanced now, but my hydrogen is not. So 2 and 6, so how can I make the left hand side of the hydrogen happy? Is if I put the 3 in front of the hydrogen, I will make it happy. So I make the changes, right? The hydrogen is no longer 2, the hydrogen is 6. So then now 2 and 2, 6 and 6, happy. So after this happy, the leftover must be 1. But you don't want to put the 1 at the beginning unless you make sure they all are balanced. So this is the answer. Now here I'm going to put the equal sign. So I have Al and I have O. So Al I have 1 and 2. I have 2 and 3 oxygen. Right? So I can start with the Al. So Al is not balanced. I'm going to put the 2 in front of Al to make left hand side Al will be 2. So my Al is balanced, but then my oxygen is not balanced. Now this oxygen on the left hand side comes from 1 reactant. This oxygen on the right hand side come with 1 product. They come with 1 thing, and this one come with 1 thing. So when they come with 1 thing, okay, and I have even and odd number, I have 2 and 3, so even and odd number. And in this case, if I have even and odd number and they come with like 1 thing, what I can do is actually I can multiply them to find the common principle, like least common principle. So least common multiple, I guess, LCM. So the 2 and 3, I multiply that, I would get 6. So 2 and 3 times is equal 6. So I have to make that from 2 to 6. I have to make it from 3 to 6. So if I want to make this to be 6, I have to multiply this by 3. Right? If I want to make this to become 6, right, I have to multiply this by 2 to make the oxygen 6, okay? So on the left-hand side, I make this by 6, so 3 times 2 is 6. So my oxygen on the left is 6, right? Now here, I'm not just changing the oxygen, I change the Al as well. So you see, my Al is no longer 2, my Al is 4 now. But then my oxygen on the right-hand side is 6, 2 times 3 is 6. Now you see that oxygen is balanced, but then now I make the Al no balance. So how can I make the Al balance? So instead of 2, I will change that to 4 on the left. So then now everybody balanced. Now in this case, like I'm showing you, I cross out the coefficient, I put it 4. Just telling you that I can actually change my coefficient even though I put the first time. I can go back to change. But when you actually do your work, you're using pencil, you will just erase the 2 and put the 4. I'm here not just showing you that, I can write the 2 at the beginning and I can change my coefficient after. Okay? But when you do the work, you just erase the 2. Okay? So it's balanced now. I think you can do number 4. And let me do number 5. So number 5, I have hydrogen and oxygen. So I get 2 hydrogen and 2 hydrogen, and 2 oxygen and 1 oxygen, right? So hydrogen okay, but oxygen not happy. So oxygen, I'm going to put the 2 in front of water, and I make a bracket. So I change the whole thing. I change my hydrogen to be 4, and I change my oxygen to be 2. So it looks like my oxygen okay, but my hydrogen is not happy. So how can I make the hydrogen happy? Is I'm going to put the 2 in front here. So my hydrogen on the left is become 4 now. So 4 and 4, 2 and 2, happy. So then the leftover will be 1. So this is the answer. Now number 6 is a little tricky. Number 6, I have hydrogen and oxygen. Okay, so hydrogen, I have 2 on the left and 2 on the right. But on the oxygen, you have to see, I have oxygen in water. I also have oxygen in O2. You have to add the oxygen number together. So here I have 1 oxygen. Here I get 2 oxygen. So totally I get 3 oxygen. But this question is a little bit different than this one, because you can see that this 3 oxygen is actually not come from one single reactant. This 3 oxygen is actually come from 2 different things. They both have oxygen. Okay, so they're not coming from one single thing. Now, right hand side, I have 2 oxygen. Now, in this case, I cannot multiply the 3 and 2 together because this 3 oxygen is not coming from one single reactant. This 3 oxygen coming from 2 separate compound or element. So what should I do? Now, if in this case, because they don't come from the same thing, I cannot multiply these together to get 6. What should I do? Now, keep that in mind. O2 is like diatomic element, right? Diatomic element is the 7 thing, like H2, N2, O2, F2, the 7 diatomic elements. The diatomic elements always have the 2. And in this case, I really hate to see odd number of the subscript on the diatomic elements. I don't want to see odd number of the subscript on the diatomic element. So here, I don't want to see O1 because diatomic element, I would like to see 2. But I cannot put the 2 here to change the subscript. I can't change the subscript from 1 to 2. So what should I do? How can I make this even subscript instead of odd? I'm going to put the 2 in front of water. Okay? So make it 2. Oxygen. So then now I change the whole thing. I change my hydrogen from 2 to 4 on the left. And then now on the left hand side, let's count how many oxygen. On the left hand side, I have 2 oxygen plus 2 oxygen here, right? 2 oxygen plus 2 oxygen. So on the left hand side, I have 4. Right? Now on my right hand side, I only have 2. So how can I make the oxygen happy? All right? I'm going to put 2 in front of this, right? So I change the whole thing. So my hydrogen is 2 times 2 is 4. My oxygen on the right hand side, 2 times 2 is 4. So now you can see everything is balanced, right? So finally, I'm going to put the 1 after. So this will be the answer. Okay, so this one's a little tricky because the oxygen do not come from one single thing. It comes from 2 things. So you cannot just take 3 times 2 to get 6. You can't. You can only change the oxygen to be 2, but you cannot add the 2 on the subscript. You can't. You can only change the coefficient by multiply this by 2 to make the O become even number. Okay. Alright, so I think you can do the rest of the question. Now here I'm starting decomposition. You see that I have only no table because it's time for you to draw your own table. Anytime with the spaces, actually the spaces will be actually for you to draw the table. Okay, and by the way, number 19 is a typo. Number 19 here should be NA. Right, number 19 here, the table should be NA. So how do I do the decomposition? It's the same thing because the opposite of synthesis. So here I'm going to draw atom, left and right. Okay, and I have 3 kinds of the atom. I have K, I have Cl, and I have O. Right? So on the left, right, I have 1K and 1K, right, left and right. I have 1 Cl and 1 Cl, and I have 3 oxygen and 2 oxygen. So K and Cl are happy, but O is not. Now this O come from one single element. This O come from one single element. You see that this one come from one thing, this come from one thing, which is different from here, right? The oxygen come from two different things. So even though this is 3, you cannot multiply to get 6. But here I can, because this come from one, these 3 all come from one single thing, these 2 all come from one single thing. So 3 and 2, odd and even, I can multiply. 3 times 2 is 6. So I have to make this 6. So how can I make the 6 oxygen? Is I'm going to put 2 in front of this. So I change the whole thing. I make that 2K, 2Cl, and then I can make 6 oxygen. And here I also want to make 6, so I have to put 3. So I change the oxygen on the right hand side to be 6. So then now my oxygen is happy. But my K and Cl is not happy, so how can I change it? I'm going to put the 2 in front of KCl. Then I can change my K will be 2. I can change my K will be 2 on the right hand side. So then now everything is balanced. Okay, so that will be the whole worksheet.